Welcome everyone to the March 10th SIG Node meeting. We've got a few items on today's agenda. So we can go through those individually, and then those items that aren't on the agenda, folks are free to raise topics once we've given time to those reserved. So the first issue here was trying to draw attention to a particular PR around pod worker behaviors. I don't know the name, I'm sorry.
Yes, hi, this is Howie. So Lantau and I found a race condition in kubelet that could cause a pod worker to stop functioning. We sent a fix to Kubernetes, but I want to bring the topic here. We think a bigger problem here is that when a Go routine in kubelet crashed, say in this case a pod worker Go routine crashed, kubelet doesn't crash, it recovers and keeps running, which makes this kind of issue hard to debug, because in this case this pod worker for a specific pod stopped doing any updates to the containers for the pod, but everything is still fine until you found out that, for example, the container actually crashed and the kubelet never restarted that container. And that may happen days, weeks after the panic happened. So I think it's better for kubelet to crash when a sub-Go routine crashed to make debugging easier. And so I dig a little bit into the history of Kubernetes, see why we have this recover behavior. And I put some link down below in the background. I think actually in 2016, we changed the behavior for all components in Kubernetes from recovering the panic into actual panic. And if you click into the 2016 link, I think we had some agreement about kubelet as well. The consensus was, even though we aren't sure if all cluster setup have some sort of system daemon to restart kubelet, which is true for Linux, but we still think it's a good thing for debugging purpose to make kubelet actually crash, and we should have release notes at that time. But actually, I think we didn't change the behavior for kubelet because we had a flag in kubelet which is called real actual panic for debugging, which sets the package level parameter into false by default. So I'm thinking this might be a oversight at that time that we never changed the behavior, but I want to propose here that should we change the behavior now, that we can either default that flag into panic and have people opt out to use the old behavior, or we can just remove that flag to make kubelet always crash on a sub-Go routine crash, and we should make some release note about it.
The issue Howie report, I think that we been discussed before. So the PR and the bug, the report before also. And so I believe that back then, Yuji and Lantau look into that one, they couldn't reproduce that problem. So there's the being discussed the crash the Kubernetes or not crash Kubernetes, and even the discuss like the once we the problem my understanding is the current problem it is when the Go routine pod worker is crash and the Kubernetes working as normal and didn't really repair, didn't self-recovery, didn't really start the new Go routine and to reconsolidate the state. That's the major problem.
Yes.
So I don't recall why, because it's naturally think about Kubernetes to crash, but then we just start from scratch, and then reconsolidate the whole state. But there's if I remember correctly, but I forgot the detail, some people don't like that idea because they have some dependency. So I just share this here because before this one is being discussed through the PR or issue. And also, I remember in the SIG Node we also discussed. So there's the pushback to crash Kubernetes. Is those like the concern? People can recall that concern or?
Well, if you crash the kubelet and it keeps restarting and crashing, you'd have no way of draining the node, right?
Yes.
Yeah, but in this case, if you restart kubelet, since it's a data race, if you don't hit it again, kubelet will be healthy for some period. And having the crash helps us debug and fix this issue.
What I want to say that what Derek pointed out, it is because we use the big crash Kubernetes. We do. Couple cases we crash Kubernetes in the first couple release. Derek just point out the one problem. That time we discussed, we think about the region. This is particularly problem maybe once you crashed and then Kubernetes will recover and also everything's move forward. But our concern it is we want to introduce that kind of model, linear model to the Kubernetes itself, because we used to also have the crash Kubernetes. And when, if I remember correctly, we used to have like the one container D, not container D, Docker is not ready, or something is like, we crash Kubernetes a couple of times, and we end up like have the series of the Kubernetes crash loop, and then cannot really come back, or even come back, then maybe like after 5 minutes, and then node is become to like an unknown state. A lot of things being evicted, all those kind of things. It's kind of the unexpected condition for cluster. So this particular problem definitely can recovery, but that's the best way we do the recovery.
I think.
I'm sorry, go ahead.
I think I can also collect what, so if we, my original proposal is that we change the behavior for this handle crash function. So I think we can do a research in Kubernetes code base to see where it uses this function and recover from the crash. In this case, we found that it's used for the pod worker go routine. And I think we should crash in that case. But if we do some research and gather what in what code paths we have this kind of issue and categorize them into like, in this case, if we crash, we think it might be able to come back healthy again. And in some cases, maybe your concern are more like, if we crash, we won't ever be healthy again. Will that help have a fine-grained control of the crash behavior?
Haven't we tried to how difficult to identify that it is the go routine crash and the pod workers crash and cannot make any progress, and then we have the signal and then we start another go routine? Is that possible? Have we tried that?
I think it's also possible, but it's basically changing the place where we detect where we have this recovery function, where we detect that the routine was crashed. Well, maybe there's another way to add a mechanism to check the, say like a heartbeat for a go routine and create another one when the old one is gone. I haven't think through about implement that.
Okay.
Yeah, I listed that as an alternative.
Yeah, I don't think I know that just the one, I think Dawn, you're right, where we do crash the kubelet if like the container runtime is not responding.
We crashed a couple cases. One case I still remember is the container, the Docker is not response. We crashed, but then later we changed that model because it caused a lot of other side effect. So we kind of in the SIG Node we say that we want to Kubernetes. We okay Kubernetes restart, right? So we okay Kubernetes to crash, but we are not artificially to crash Kubernetes because we still want Kubernetes report. Because we want Kubernetes, we think about Kubernetes the brain after that node. If we want to say this node is the K node, Kubernetes node, so we want to Kubernetes response the node healthiness, right? So then there's a lot of the metric stats exported through the Kubernetes. So that's kind of the way we made the decision. We, of course, all those kind of things totally makes sense at a given time. So now Kubernetes is totally different. Kubernetes also is different, evolve a lot. So we could change it. And, my concern, one concern it is this case is definitely helpful, but we started to reintroduce that to crash Kubernetes mode. And there are many other places could be crashed Kubernetes, and it could be like the one mode, right? Introduce to new mode and then introduce the new mode and then become to the crash loop. That's a little bit concern. So I think that for a lot of people, crash loop may be also okay because Kubernetes, and another thing my concern it is certain feature. Even Kubernetes, we are clearly say we don't want Kubernetes checkpoint, but we do because Kubernetes also is extended mode, right? So it's a model. So there's the component plugged into evoked by Kubernetes actually did some checkpoint. One of my concern it is if Kubernetes itself crash, and at least we could detect those checkpoints by the corrupted data record. Right now it's more like the plugin mode, same as the Kubernetes. So there's the people doing the Kubernetes crash could be corrupted their checkpoint, their individual modules checkpoint. So that may introduce more problem. This is just my wild guess, but we saw this before.
But the core issue here, though, like I'm wondering if we had a way to just detect a hung pod worker.
Yeah.
And a way to monitor that. Would that have been a good intermediate? We could follow up on that. I don't think we have a great way right now of saying that a pod worker is hung.
When we say hung, we mean like it crashed, right? Yeah.
Crashing. No progress.
And in this case, actually, specifically, it happens to static pod workers, so not all pod workers, I think.
So, like, if we had a way of like reporting a counter on the number of workers that crashed, is that a good first step?
So, but Derek, actually, this problem really give me some like I think a lot of problem we saw the issue filed like they say, oh, I noticed that the container is die, and I noticed that the pod so I believe like the easy to find the pod is not running and stuck at the pending state, and the Kubernetes didn't really make progress. That's relatively easy for people to spot that problem. And we looked into those kind of problems before, and we didn't notice that the Go routing crashed. And we think about this as a state mismatch. And a lot of time workaround we suggest of the user customer, it is delete that particular deployment, right? The instance. And then, but there's the problem, it is actually pod is running successfully. Pod is in the running state, but it could be like the container is in the bad state, but it's not detected because the pod worker is just crashed. And that's actually is much harder to detect, right? So this is really, just thanks to find this bug. I just want to pass about out because I think if couple of years I saw those problems.
If we crash, we'll be incentivized to be better. So like part of me right now is like, we should just crash.
And my hope is that with the system daemon restarting Kubernetes, everything will go fine. But yeah, I'm not sure what potential risk there will cause the Kubernetes to be into a crash looping state.
We should definitely make sure that there's a metric for number of times kubelet is starting, surfaced up through the components. Like anybody who has a Prometheus system should have an alert for that today. I'm pretty sure that doesn't exist because I've never seen it fire.
Yes.
And I think this would be an obvious one. Like if kubelet is starting multiple times at a rate higher than like 1 every 10 minutes, something is, or 1 every hour, something is wrong.
Yeah. So actually, we do have the NPD. I think the NPD have one of the problem detector, the plugin, which detect this container runtime and the Kubernetes in crash loop. I forgot the time interval, like the 10 minutes or 15 minutes, and the Kubernetes or Docker in crash loop.
I think they may be using a counter of.
Yeah.
Oh yeah, it's like
giving interval. Yeah. So how many times? So I forgot a detail. So basically, that it is using to detect this kind of problem. And anyway, so I just threw out here. One of my major concern it is because each component, which is plugin, and in Kubernetes, and in the past they did a checkpoint, and those checkpoint because due to the Kubernetes crash and in the corrupted mode, and then cause the Kubernetes cannot really, which is their plugin, cause Kubernetes cannot really start.
Yeah.
So
is it, I forget, like if everyone in the world is going to be probably launching a kubelet on a Linux host on some systemd unit, that's going to have some restart on failure. I can't recall right now if there's a simple way to figure out from systemd how much it's done that restart. I want to go check that, but assuming anybody in production could wire that in their monitoring system, I think that's probably easier than taking on a node problem detector dependency, but maybe we can just take that as an action item. But in general, I feel like crashing makes our product better. So, yeah. And the checkpointing, it's a concern, but we tend to have an aversion to checkpointing anyway. So maybe it makes checkpointing better too. But yeah, I think the first thing is to check if there's a simple monitoring rule we could put in place to recommend folks if systemd keeps restarting kubelet on failure.
We should probably look, I know the Prometheus node exporter has some systemd metrics. I don't know if it has like a restart count sort of thing, but I know that it has a bunch of systemd related stuff that if it doesn't have what we need, like maybe the right place to put it.
Okay. Yeah, I think I can go to verify if systemd and Prometheus exporter have some way for us to detect the restart. And if it has, I might go to send a issue or PR.
yeah, definitely. Yeah. Thanks for file this issue and debug this one. This is actually, yeah.
Looks like systemd does have a restart counter. I'll just put in the notes, and we can probably feed off of it.
It looks like it shows up in the Prometheus node exporter. I don't know if that's what you're referring to, Dick.
I was just looking at the systemd code itself. And so I'll put a note here we can follow up on.
It looks like you may have to specify a flag to turn it on.
Yeah.
Looks useful.
Yep.
We can discuss. I think that you really want it is this problem export to cluster level. Say, oh, this Kubernetes is in crash loop. And I'm not sure the systemd. I know system have the restart account, but I don't think they have like the interval. They do have like the between each restart they have the interval, but they don't have like the how I'm going to measure this is the crash loop.
I think
Like the total interval and how many Kubernetes, how frequently Kubernetes restart, and then I think about you need to pay attention. So that's alert. type of the signal. I think that's what I mentioned, like node problem detector. We detect that problem based on the giving total interval and how frequently you restart Kubernetes or Docker and say this node is okay or not okay. We can talk about this more, and if we finally decided to introduce this the crash back.
Okay. I guess the PR in question, we should get this merged into 118 back to at least 115.
Yes, that's it.
Yeah.
That's it.
Yeah, I think so.
Okay. All right. So the next topic, if we're ready to move on, is the cap that was open for pod level resource limits.
Yes. I'm not familiar with Zoom. Is there a way for me to share the screen, show a few slides I made?
Yeah, it should be possible. There's a
Yeah.
somewhere a screen share button.
Oh, yeah, I see it. 1 second. So basically, what we're talking about is a way to make it possible to share limits across containers in a single pod. So a little bit about my motivation to include this. I'm working in a product called the Business Application Studio at SAP, which provides an development environment, an IDE as a pod. So each user would get basically his own pod that simulates a full development environment. And in our product, basically, it is extensible in the sense that tools can be added into the base deployment as a set of sidecars. And what we have figured out is that when we do that, it is very difficult to accurately describe to Kubernetes on the container level the set of limits and the set of requirements for memory for each one of those tools, because it very much depends on what the user actually wants to do. So if one user wants to compile using one tool, another user wants to compile using a different tool, they would probably benefit from different limits and different memory requirements for each of those containers, providing each of those tools. And what this is about is actually maybe enhancing or extending the way that Kubernetes sets up the C groups on the pod, so that instead of setting up the resources on the container level, it would be possible to set the resource limits on the pod level. There is already a C group for each pod. That is something that has already merged into Kubernetes. Basically, if we look at what exists today, then every quality of service, guaranteed, burstable, and best effort has its own C group. And under that, there would be another C group for the pod itself. And under that, for each container, including the pause container, there would be an additional C group. And the limits are actually set on this level. For guaranteed, it actually today is already setting the limits also on the pod level, but it doesn't actually matter because there is no way that you could escape the limit that is set on the container level. So it makes no difference if this is set or not. And in today's implementation, the pod level on the burstable quality of service is only set if you actually did already set a limit on all of these containers. And
just,
yeah.
if it's okay, it's a beautiful chart. And so I just wanted to note that guaranteed pods are peers to the burstable slice. And it's just because there is no guaranteed slice. And it's just because the way CFS is evaluated among siblings. So when we talk about why the burstable limits were summed, it was so that CFS sharing is evaluated with the right ratio across guaranteed pod and the burstable tier.
Okay. So basically what my proposal is to allow the user, if he so decides, to specify to the kubelet that for specific pods, there should be a limit set on the pod level, even if it was not set on each and every one of the containers in that specific pod. And this is an opt-in behavior. So if the user wants to keep the current behavior, that's okay, no change. But if the user wants to have this pod level resource definition, it would set the C group limit here. instead of setting it in each of these containers.
Yeah, I understand where you came from, but I
Mhm.
have a question. I think about the if you the why we convince ourselves it's easier for user to set that limit or request limit at the pod level instead at the container level. Because each container actually really represent is a binary or it is application, so they can much easier to through the C group actually is the same to measurement, but really for the pod, and if we think about Kubernetes, a lot of the feature and going even like in the before, like there's init container, sidecar container, and the booting, and so it's how I personally feel like I think about for me, it's much harder to set at the pod level because the pod level resource usage is not always controlled by me as a developer. So
Yes.
I want to roll out a certain application, and but I want to benefit by Kubernetes, all those functionality services you give to me, and I end up to schedule, I do the deployment. I could end up have some other container, some other is not out of my control, and in share the same pod. So from that perspective, actually it's much harder to set at the pod level. I just
Yeah,
want to do
yeah.
this.
I completely agree. I will get to this. I have a slide, I think, forward to discuss the two alternatives to implementing this. Let me just get to that, okay? The advantages of allowing these pod level limits, well, for me, it makes sense because it means I don't have to micromanage the container limits in my specific use case. And I don't need to give unlimited resources to specific containers, because the current behavior is that if I don't specify a limit for all of the containers, then basically those containers that don't have a limit are unlimited. And that actually also causes some sort of a noisy neighbor problem. So pods in the burstable quality of service level that have containers that are not constrained are actually able to consume all of the resources that belong to the host. And this would actually make it possible to prevent that.
Yeah, so that last part's not necessarily precisely true. Like, so we could cap resource consumption at the QPod slice or the
Yeah.
QPod level.
That is true but still there would be contention between the pods that are running on the node, even if the kubelet itself or the system itself would be able to continue working because they have their own slice. The burstable pod would still be able to consume more resources than even a guaranteed pod living on that same node. Okay.
Well, it's only going to be evaluated relative to other pods in that same burstable tier.
Yeah,
Like, so because the time slicing on CPU is going to be at each level in the hierarchy. It's not going to be evaluated across all pods.
That's true for CPU, but for memory, because memory is not compressible, in the end, it would get to the point where this single pod could theoretically prevent somebody else from using the memory, and that would be a bigger disruption.
Yeah, so the part with memory that is probably then back to Dawn's statement, which probably you'll have a next slide about, is just what happens when I put an ephemeral container in there to debug your pod.
Yeah.
And then the other thing was just make sure, I think I commented on your cap, like pod resource overhead that is in flight with Eric's work. We probably would want to know how to interact with this.
Okay, so I'm not exactly familiar with the pod overhead. What I understood from what I could find is that it describes a amount of resources that are a priori assigned to the pod for consideration by the scheduler, right? It's not.
It does a pod C group as well. It sets up the C group that the containers run in. It'll add the overhead in it because instead of just running those individual containers, you could be running pieces of cryo or container D, perhaps, or you could be running a virtual machine and using that to isolate instead of just namespaces.
Mhm.
So you would essentially kubelet would go in and size the pod C group accordingly to the sum of the requests plus that, and then it'll update the CPU shares as well.
And I understand how that works for guaranteed pods and also for burstable pods where there are limits for all of the containers. But
Yep.
for burstable pods where there are not necessarily limits on all of the containers, does that actually do anything? Because the C group
It
here
has to have the limits actually set, right? Because if it's completely burstable, you're not actually enforcing for best effort. It's kind of that if else of if limits are defined for everything.
Yeah.
But I think the pod overhead, we definitely need to figure out the interactive between this one and the pod overhead. But I think about that we treat pod overhead as the tax have to pay. Once you install that one and you allow that feature, it's kind of the tax for all the pod have to pay. So I think the interactive between this pod level limits actually could be relatively simple.
Yeah, I think so.
Yeah, I also think about the pod overhead actually make this pod level limit is possible because we talk about the pod level limit before many times, and one part it is just introduce this variety actually came from the pod overhead. Because that time we start talk about the virtual machine and we talk about some different of the container isolation technology, all those kind of things. We think about the overhead is hard to be identified. It's not like one number, right? So like the before. So now we have the pod overhead concept. I think the perfect timing to revise of the pod level limit.
I was going to say that I had heard a lot of other people as well kind of describing a desire for pod level limits. I think that the difference is that they don't want to care about anything with respect to container resources. So whereas I see this cap is kind of talking about burstable specifically, guaranteed, it doesn't really matter. It's already all signed up. But I think the other end of the spectrum is where they don't want to specify anything.
Yeah.
And they want to have it set up correctly. So I think that having some notion of support for best effort, I think would make sense. But yeah, you know, when I was looking at it, I wasn't sure how to tie this to QoS necessarily. And it seems like, you know, that's the way you were thinking. I was just looking at it kind of generically across the board.
Okay, so maybe I'll get to the next two slides, which are the two different implementation options, and then maybe we can discuss exactly what the best way to implement this would be. And obviously, the first implementation option would be to put this on the pod level and something like this. So you'd set a resources section on the pod itself, and then you would limit it however way you want. But actually, I agree with what was said here before. It's not that convenient because that would mean that I would need to calculate all of the limits myself, and I would need to somehow figure out what the correct limit for the pod is. And in cases where you have something like Istio that is adding additional containers to my pod, and I'm not actually in control of that, I wouldn't know necessarily how to deal with that. And also, if you upgrade Istio, and then suddenly the container limit that Istio injects is different, and then everything breaks. So I'm not really a fan of this option. I was thinking of something a little different. What I was thinking was to set a Boolean on the pod level. I'm open to suggestions for the name, not married to this name. It's just kind of hard for me to figure out a more descriptive name. And basically what this would do, it would set up the C groups in the following way. Any container that defines a limit would still get its limit defined on its level, but the sum of all the limits would also be set up in the pod level C group. What that would mean is that if you're interested in capping the limits for all of the pod, you basically need in one container to set the overall budget for the pod. And then all of the pods, all of the containers that are included in this pod would not be able to exceed the limit that was set in the pod level C group. That would mean that it would be possible in the example that you can see here to limit the shell to only use 128 megabytes of memory at most, simply because the sum of all of the containers in this pod have a limit of 128 megabytes of memory.
I apologize. It's not clear to me how the first advantage bullet holds. So like, if you go to the Istio example of injecting a container and Istio container did define a limit, how does that not impact this?
It would not impact because we would sum that limit and add it into the C group on the level of the pod. So if Istio says that it needs another, I don't know, 128 megabytes, then that is in addition to all of the limits that are defined on the rest of the containers that,
What if-
that are actually in my pod.
Okay, so I was slow there, I'm sorry. So basically, if my container doesn't specify a request, you don't have any change here. But only if it had a limit do these get summed, okay.
Yeah.
All right.
Okay, and in this
there was
case,
another option I put on the KEP, which was,
yes.
is this really something end users understand, or is this something that could be abstracted behind like a runtime class?
Yeah, so I think if we abstract it on the runtime level, then it becomes a lot harder to use. Because that would mean that if I want to set a budget or a limit, I would need to, a different budget or a different limit for different pods. I would need to define a runtime class to go along with that different budget or different limit. And that would create an explosion of runtime classes. Also, you might need to start giving permissions to developers that are not necessarily a good idea. The admin of the cluster needs to be able to define the runtime classes, not necessarily each and every developer that wants to deploy something on that cluster.
Yeah, that's fair. I was trying to work out if there's any complications with the Kata use case where I hadn't thought through.
I mean, with Kata, we just today do a summation of the containers, and that's what we said. Actually, we don't. We just, in the Kubernetes case, take and mimic what is done by kubelet already. So that initial pod C group value. If it was explicit, and the pod spec said that this is what the pod level resources are, that'd be great. But
I think that at the chat, and Mac Brown raised a concern. Mac, can you talk? If you cannot talk, I will read what you.
Yeah, I can talk. I'm just making mention that since you can't shrink the memory allocation of any particular container, you're going to have to also consider stopping and restarting long-lived containers in this model, right?
Sorry, I didn't get it.
Well, once you expand the memory limit of a container, you can never go back.
Yes.
So if you're sharing these burstable limits, you run a big risk of running out, right, of memory.
So I'm not sure if that is the case. So if you define the limit on a upper level in the hierarchy, in the C group hierarchy, and then you allocate that memory in one container that does not define itself a limit, but then you free that memory and you try to use the same.
Oh yeah, right. Store stop, right.
Yeah.
It depends how you're freeing it, right?
Yeah.
If you're freeing it via start and a stop of the container. I was just mentioning that. Right?
Not even a start and a stop of the container. So even if the process that used that memory would just release that memory, that would also release the allocation, right?
Yeah, but I can't shrink the memory allocation that I've shared or allocated with that container.
Okay,
You'll
so
get Linux invalidates any attempt to shrink the maximum limit.
Okay, so I will double check that I actually get the behavior that I want in this case.
Yeah.
So the other question I have is, what should the killer do? So how do I decide which container to kill when one is consuming too many resources with this model? Do I do anything differently? Or today we set score just relative to usage versus request. And I'm not sure if you would desire that same semantic when sharing resources across your containers. Had you thought about that?
I did not. I need to think about that a bit. I'm not sure that it needs to change that much. I don't know. I need to think about it.
For the first option, are you proposing that users can only set limits, or is it also possible to specify pod level requests?
I don't think it matters if you set the request, right? The request is only used by the scheduler.
You set the shares as well with requests.
Right. I'm mostly just trying to figure out what's in scope for your proposal, not.
Yeah, so I'm mostly interested in the limits, not in the requests.
Okay.
I think when we prior discussed this, David, I feel like I've always been interested in overcommitting the pod itself. And so
Yep.
being able to set requests and limits on the pod was useful if I wanted to overcommit the pod. But if option isn't an option you want to like deeply pursue, then maybe just focus on option 2.
So I would prefer option 2. The question is if this is something that appeals to the rest of you.
I think if we're going to go ahead and do this, it would be nice to be able to do something like best effort, which I think option 2 isn't going to be able to necessarily cover. And they're naively haven't not thought nearly as much as you. I would think option 1 would require a decent amount of validation of checking what the pod level is versus what the different C group requests are, and make sure that one is bigger than the other. But for me, that would maybe be the most useful, so that way an end user can just go ahead and say, all I care about is setting the pod, and the workloads can figure it out. I don't really care. If you imagine kind of giving out a pod to somebody who's doing different container builds or testing or things like that, they don't really care what the end user does with it, but they just want to dictate that the pod only takes up so much so that they can start packing it. I don't think you could necessarily do that with option 2.
I think you can, because in order to do that, what you would do is you would set up a container in the pod that defines the ultimate limit that you want to give to the entire pod, and set this Boolean value to be true, and then you would get that behavior.
I thought it was summed, and if a pod doesn't specify limits, that means unlimited. So
there has to be at least one container that sets limits, because otherwise you're in the best effort quality of service environment.
Right. Oh, I thought that was what Eric was asking about.
Oh, so you mean, sorry, so that I understand, you meant that moving this, instead of being in the burstable quality of service level, to move this towards the best effort, and then have the resources being set on the pod level?
Or make it maybe not really tied to quality of service.
Okay.
But I'm
if
not
you
sure
don't
if that's a
tie
good idea or
quality
not.
of service, then that becomes a bit difficult to reconcile with the quality of service concept. Because what would you do with guaranteed pods in that case?
Well, it's already basically shared at the guaranteed clause tier, right? It's just individually bounded by each container therein. Exactly. So it doesn't change the meaning of anything.
It would have basically no effect in that case. It would be a definition that you would need to validate in, when the pod is being checked to see that everything is okay. In the end, it would mean that the developer would need to, in his head, verify that the sum at the pod level also matches the specific values in each of the containers. It's additional development overhead.
And then the only other thing I'm wondering about as I look at this is I see Victor's on here, but I don't know if anybody else from NVIDIA or Intel's here, but what impact this has for folks who wanted to have memory aligned CPU and devices and the whole NUMA stuff going on. So like right now, many of those decisions are made on a per container basis. And so I don't know if sharing at the pod level would introduce any immediate concerns. I can't think of any right now, but this gets into a complicated mental space. And so I don't know, Victor, if you had thoughts or anybody else had thoughts on what this would introduce.
No, I don't at this point, but I can certainly take a look at the CAP and, see if that would have any impact. So that thanks for bringing that up. I don't see anything at this point, but I haven't looked at the cap.
But I do have a concern. So there's a couple concerns I have, but I just want to name one because the other concern I haven't very clearly thinking through. So one concern I have, it is based on this one, your use cases you described, I think it's totally fit with the option 2. But could be use cases and the user really know what the container, like a given container of that resource. So they want to carefully think about what's the peak usage, what's the average usage. So they schedule that one based on the request and make that is the burstable and have the well-defined of the request and the limit. And but then there's some other whatever container injected into that one and they don't know. And so they don't really specify limit. In that cases, you could end up like the assistant of the container in that application could be using because you mark this shared burstable limit to the potentially that a container, the whatever is a helper container or whatever container could be using all the usage, all the allowed of the limit to that in that pod. So to me, the potential is have the reverse priority issues here. So I want to my well-defined container like all those kind of web services, all those kind of things, and I calculate. I say okay, average usage that is as the request, and then peak usage is limit. I'm the well behind of the stated. So now there's the something and somebody provide something and inject into my pod for the deployment. But they couldn't because they have no idea. They provide infrastructure or services for everybody. So they cannot predict what is the real usage it is. So they unlimited. But that could be using most of things. And then that's back to the Mac Brown. Actually, he mentioned something. In that case, a lot of time it's not that easy to release of the memory. Depending on the memory type, is such certain memory even cannot reclaimable. So always goes to pod, goes to like a parent level. So even a container die, it's not all the resource usage, like the certain slab usage is not released. And this goes to the pod level, pod destroy, it goes to the root level. So a lot of time, if you measure carefully, you can see that the slab usage keep increase. So you end up to have to force node reboot to release those kind of the memory. So end up like you could like the really heart of you well design of the application here. So I just want to show this one. This is the one of the concern I have. I have the couple other concern, but the other things I haven't thinking through yet.
So this is obviously something that somebody who wants to use this would need to opt into it. If he doesn't opt into it, then he still gets the current behavior, in which case that injected container would still be unlimited, exactly as it is today. I agree that in a scenario, in a cluster where there are multiple additional helpers, admission controllers that inject containers into pods, you could end up not exactly knowing for sure in the beginning where you're going to end up in terms of memory usage. But this is, I think, something that is more descriptive of development environments, in which case it's easier to recover and prepare for those production environments, at least I think. So while it is a concern, I think it is manageable in this case.
Do you have any, did you work through any scenarios where init containers were used, and if you'd want to shrink the pod size differently based on if init containers were created or deleted or had already completed?
Sorry, could you repeat? I didn't understand.
So you could have a pod whose like init containers run in sequence, and so
Okay.
I was curious how you thought the burstable limit should be applied during the init container.
Yeah, so actually I didn't give enough thought to the init container phase of the pod lifecycle. I need to recheck that.
And then for your example, are you using like memory backed volumes as a scratch space in your developer?
in our environment, we're actually using not memory-based volumes, but empty dirs based on the host file system. So no. I think since the size of the ephemeral memory-based drives should also come from the memory C group, it should also allow you to be able to limit the RAM drive to the size of the pod C group.
That was going to be my follow-on question, which was, do you want scratch space to be shared across containers, like ephemeral storage, CPU, and memory? And if you were using memory with empty dir back tempfs, then you probably would hit the situation that Dawn talked about.
Yes.
And then if you're using ephemeral storage, either scratch space in the container or like a local volume or something, it wasn't clear if you wanted scratch space to be shared, because I could see an argument that that's also hard to size on a per container basis. So
how is it limited? Is that also a C group or a different C group?
It's not enforced at a C group level, but there is a loop in the kubelet that enforces ephemeral storage. So I think in the interest of time, I know there were other topics. We've spent a lot on this. Maybe we could give a quick chance to let others get their items raised if it was quick reviews, or I see Clayton also typing a huge number of notes here. Can we follow up on this on the KEP and then maybe sync up again in a week or so to see if people have more thoughts? Cool.
Thank you.
I just want to say that thank you brought this up, and it's the good timing to revise this thing, but iterate those things. But I think this is the big topic, and it's complicated topic actually, and we cannot draw conclusions soon, so we need to carry on the discussing. Just want to let you know. Yeah.
Sure. Thank you.
Thanks.
So Victor, it looks like you were calling out for documentation PRs, is that right?
Yeah, there's just 2 to finish up for beta. But the last one, with the recent merge, we did break the Windows platform. And, you know, what I'm wondering is there a CI job or something that we should have run to like prevent this in the future? Or I'm sitting there wondering, how do we miss this and let this in and don't do it again?
I think everyone's probably done this at some point. There is a incantation you can run that, depending on what you broke, if you broke a build or something, there is a shorthand you can put on the PR to test all the platforms, I guess, but I wouldn't feel.
It built correctly for the Windows platform. It just wouldn't start on it.
Oh, okay.
Yeah, this is where the pod admit handler was nil. Windows is returning nil for the handler, and it at some point dereferences it and blows up the kubelet, fails to start up. They've got a pull request over there, and there's been some comments. So the other thing, ask is, okay, we broke them. Let's maybe help get it in.
Okay, we can follow up on that one. And then in the 4 minutes remaining, I don't know if Matt or Clayton want to flip a coin on who wants to take the time.
Clayton, mine isn't super time sensitive because I'll be out on vacation next week. So if you want to go ahead and we can.
No. Mine. There's no rush on mine.
Well, equally no rush on mine, so I defer to you.
Unless you.
I guess we'll just go home then.
I'll take the time.
Go ahead.
I think Alex just joke.
Unless you want to review my document PR, I would suggest someone else goes.
I was going to nominate you, Clayton, because Seth wanted to hear your notes and words. And so.
Okay, that's fine. So I tried to capture all of it in the agenda. I've just been spending, as I was in, I was looking at something in the kubelet and it caught my interest around Status Manager. And it's been a while since we've gone in and touched Status Manager. So I was looking at, I think there's a lot of room on the table for improving the end-to-end latency from the time we detect that a status update is necessary in the kubelet to the time it's written to the API server, especially in busy nodes. So one of the things is we kind of have a real simple like here's the stream of updates that need to be happened, and then periodically resync everything. And that's a good mechanism. The problem is that after a certain point, because it's a single threaded process, when you get about more than 10 pods on a node, there's a good chance that you're just in the reconcile behavior always continuously, which isn't bad, but that like maximizes, like P99 latency is pretty bad on that. So I was looking at a couple of simple changes, getting familiar. The big thing was that there's definitely some room for reorganizing the code just to make it more readable. While doing that, Jordan and I caught a couple of bugs that are just, you know, as we've evolved, there's some obvious things in there that we can fix. I talked to David Ashpool and he gave me his brief on what he'd done before. There was probably like 4 or 5 things we can look at. I did some simple ones, which is trying to avoid the live get, which is actually very expensive in big clusters because reads are blocked on range locks today in some cases. And so in a big cluster, lots of nodes doing live reads all the time of pods is very bad. And there's not actually any safety when we do a live read because in between when you do the live read and then you generate a patch and send it back to the API server, multiple other people could have written. So I think that right there is probably the biggest win. And then another one I was looking at was prioritizing which updates go out. And the updates that go out that really matter are when a pod becomes ready or when a pod becomes not ready. And then when a pod transitions to succeeding or failed and is ready to be cleaned up. So right now I'm just prototyping and I will pull this together in a KEP, but I think there's a ton of low-hanging fruit that should help us cut P99 of status updates and pod end-to-end times pretty significantly. Certainly may not show up in the overall numbers, but at least in an EDE run, you know, just like as a micro benchmark, I was able to cut the total time spent waiting to send a status update to like a 4th or a 5th of what it was before, just with some basic improvements. And so I think there's some more room there too, so we can get tighter tolerances on something changes and how quickly can we get the API server to reflect that.
Did you mean to say 800 seconds?
So if you sum in an EDE run, if you sum how long we spend waiting from the time when we detect that a status update is necessary to the time where we send it, it's 800 seconds over the whole run with some basic improvements that I think are still sound, like from a correctness perspective. And obviously like we have to be really careful because we had lots of issues with stale reads. The thing is the live read doesn't prevent stale writes because of the way we're doing it. So we still have some issues there, but I was able to get down to about 200 seconds of waiting. And that was just by avoiding the live read and using a recency cache. You know, we're the single writer most of the time for a pod, and we already have detection to go mitigate when somebody else comes in. So
I didn't think that was true though with Readiness++. I thought we might be a single writer anymore.
It doesn't even matter though, because all of the same, like the thing is that the current logic is somewhat like, depending on a live read doesn't guarantee you a live read because in between the time your read completes, someone else can go write it. So we're doing an inconsistent operation after a consistent operation doesn't protect us. We just have to be sure we're consistent with ourselves and that we're not, the other part of this is like, as part of this, we need to add a lot more EDE tests about multiple writers explicitly, like on the previous work I'd done for like pod termination, just having an EDE test that stressed pod termination found 5 or 6 issues. I think we need to have a multi-writer to the kubelet, multi-writer to pod status EDE test that specifically stresses this. And I'm sure we'll catch stuff today that we still need to fix. So it's more of just I'll try to pull some thoughts together when I have some more data, but I think there's a lot of low-hanging fruit here to speed up and improve general correctness of the kubelet status loop.
Just for clarity, you're only looking between API server and kubelet. You're not looking at the CRI.
There was definitely, so I flagged something for Mernal to look at with CRI, which is that none of the CRIs return typed errors. So in a lot of error cases, we do the worst possible thing. So like you try to start a pod that's already been deleted or start a container that's already been deleted. The error message says this container doesn't exist. And in a teardown case, we could probably cut 1 or 2 seconds off a lot of teardown loops because of that. until the pleg's going to be behind.
Interesting.
But because we don't have a typed error, we just do the naive thing, which is correct, which is retry later. There's probably a big win on pod teardown if we can get typed errors back from CRI for not found. That alone would probably save, like pod teardown's pretty bad right now. It can take up to 10 to 15 seconds.
I got you. You're looking for low-hanging fruit then. Yeah.
Yeah, I don't think there's nothing in here felt like there were going to be massive wins with big rewrites. It was lots of low-hanging fruit. We're mostly correct. We could be more correct and much faster and put tests in at the same time. So that's kind of the mindset.
Cool.
Okay.
Cool.
Yeah, we sort of go with an inventing model though. Just a heads up, in most of our architectures, we don't use the polling loop so much as eventing.
Yeah, and the eventing is actually pretty good. It's just the interactions, like the pod worker interacts poorly with a status loop and vice versa. I think
right.
One of the things that we can do is actually look for places where just the information flow is bad. The nice thing is that we have, like, most of this was pretty obvious just looking at the kubelet, which just goes to tell me that, like, nobody's really sat down and like put the kubelet through its paces and some of these, like, what happens if I delete and recreate, create and delete a pod immediately over and over? And there's a bunch of issues that jump out. Getting more EDE tests in that verify those kinds of flows will put us in a much better spot in general.
Yeah, we test that in Cry, but yeah, that makes sense at the E2E level as well.
Yeah, and I don't think Node EDEs would even catch some of these because it is specifically the interaction between the two parts of a distributed system, and the races that can occur aren't always obvious if you don't have fairly realistic flows.
We also have we have the Node ETE, but the problem is Node ETE is nothing really conformed, like using those, but the certain scenario actually you want to stress on the node. It's much easier to stress on the node, but we never figure out how to, we end up simplify our node ETE and raise of the node level of the conform test to the cluster level, but obviously we lose a lot of the stress part of those things. Anyway, that's the second stuff. Yeah, but I really appreciate that you look at this one and part of those things. And it's right timing. And recently, actually, we do have the people, vendor, or you can think the user came to here, and but it's the different cases. That's the circular dependency things, but also related of the pod status, latency. Yeah.
Yep. All right, that's it. Thanks.
All right, well, I look forward to Mernal opening the KEP for CRI error messages. But I think we got through all the topics then, and Matt will pick up your topic next week. And thanks everyone for a lively SIG Node, and talk to you later.
Take care, everyone, also in this special time period. Yeah.
Thank you.